What am I looking at?
Well, actually, the critical object is this one, which is a bubble chamber, okay? And the situation is this. Here is the accelerator, and here you arrange it so that a beam that's circulating here hits this target. Oh, sorry, I was going the wrong way. It's going this way. So it hits this target, and it emits particles which then have to be treated, and they continue until they reach this bubble chamber. This may be about a distance of probably 120 feet, okay?
Mm-hmm.
So that's this gadget. Now, this was prepared, well, okay. These objects
These things, right?
are called separators, and they have a large, very large electric field in them. These things are magnets. But anyway, they have a very high electric field in them, and if you are not careful, you get this problem, that the
Yeah, I'll do that.
well, obviously that there is a lightning that goes from the center to the outside. And when you do that, the director of the laboratory gives you hell. And of course he says, why aren't you more careful?
So this is an insulator of some kind?
The outside, I mean, these things that I pointed out, the separators are round. And this is the outside. There's a metal, they sit in a metal tube, and there's a central wire going through them, okay?
Got it.
And there's a difference in electric potential between the two, right?
Yeah.
And if you're not careful, you get a slight amount of damage. Okay.
And the main purpose, what's the main purpose of the
Now
machine?
I'll explain what the whole thing is about.
Okay, you need this back?
Yeah.
Okay.
Actually, this was prepared when the all right, I don't have to talk about that. Basically, you want to study particles that reach the bubble chamber. Now, can I have this book? Just to brag a little bit first, this book contains the Nobel Prize lecture of Louis Alvarez, okay?
Got it.
And one of the few pictures he lists is this, okay? Which actually was something that I designed and developed, okay? As I said, the lecture is by Alvarez. Now the problem is this: when the beam inside of the accelerator hits the target, it emits maybe 100,000 or 1,000,000 particles that are shot through the bubble chamber. And that here you see the beam going through the bubble chamber before it reaches any of the accelerators, okay? Now in this group here, where there may be between 100,000 and 1,000,000 particles going with the speed of light practically, there are about 4 or 5 particles which weigh more, okay? And they are the interesting particles that you want to study. So when you turn on the first separator, you can see quite a few are eliminated, and this is the beam looks after one separator, if only one separator is turned on, okay?
I see.
Now when both separators are turned on, you actually start seeing the individual
The
particles that
particles.
you're interested in. And there are only about maybe 5 or 6. So you're finding 5 or 6 particles among hundreds of thousands with which you start, just because they weigh more, okay? A little more.
And thus that's why it's called the particle separator,
Yeah.
because
Okay.
that's how you would do it.
So I was quite pleased with that.
Very nice.
I might say what you're really separating is particles which move at a speed which is 99.8% of the speed of light, and the particles you are trying to study are those that move at the speed of 97% of the speed of light.
Wow.
Okay? And that's the issue, is how to separate those two.
Just,
And that's what this system does. Okay?
wow. Spectacular.
Hmm?
Well, congratulations. What year was this? When it was?
Probably in the 70s.
In the early 70s, probably, right?
And of course, the director of the lab was Louis Alvarez, and he got, based on this type of work, he got a Nobel Prize. Okay?
All right, that's a cut.